Hello everyone, my name is Kanika and I will be starting with another interesting topic called cubes and cube roots. So let's understand through slides what this topic means. Let me share my slides with you. Alright, so the weightage for this chapter in the exams is 11 marks, and let's understand how do we solve and how do we get cubes and cube roots of a number. So in this, we will be talking about how to find out the cubes and how to find out the perfect cube numbers. Also, we will be learning how to find out the positive and negative numbers, like cube roots of positive and negative numbers. So let's understand them one by one. First thing is, we will be talking about a perfect cube. A perfect cube is the number that is a cube of an integer. So in this case, we will be talking about the perfect cube of a number. Like for example, we have 125. So 125 is a perfect cube because 125, how do you write the prime factorization of 125? It's 5 into 5 into 5, which is basically 5 raised to the power 3. So that is why 125 is a perfect cube. Cube means what? When a number is multiplied by itself thrice, like if we talk about a raised to the power 3 or a cube. So this means a is multiplied by itself thrice. This is what cube means. Like in this, they have taken the example of 125. Now, okay, one more thing. A can be any integer. Either it could be positive or negative. You can take any integer. So if we talk about the cube of 5, that would be 125. And if we talk about the cube of minus 5, for example, so minus 5 whole cube would be minus 5 into minus 5 into minus 5. So we all have done the integer multiplication. This would be minus 5 into minus 5 is plus 25, and plus 25 into minus 5 would be minus 125. So what we have learned in this case is, for a positive number or a positive integer, the cube is always positive. And then if we talk about a negative number, the cube is always negative. And if we talk about cube roots, so cube root is the opposite operation of a cube. Like for example, the cube root of 125 is 5. Like how do you get 125? By multiplying 5 3 times. Similarly, we have 12 cube. The 12 cube would be 1728. And the cube root of 1728 is the opposite, that's 12. Cube root of minus 216 would be minus 6. Cube root of 8 by 27 would be 2 by 3. And cube root of minus 125 by 216 is minus 5 by 6. And the vice versa would be, the cube of minus 6 is minus 216. Cube of 2 by 3 would be 8 by 27. And cube of minus 5 by 6 would be minus 125 over 216. So this is what the basic gist of the chapter is. Let's move further. These are the various examples of perfect cubes given to you for positive and negative numbers. So perfect cube 1, cube root is 1 and cube of it would be 1. Cube root of 8 is 2, cube of 2 is 8. This is how you can understand the cubes of 1 to 10. And you can find out the cube roots as well in the same manner. And this is the following table which represents the cubes and cube roots of the negative integers from negative 1 to negative 10. And this is from positive 1 to positive 10. So you have to learn these because it will be easier for you to solve the questions then. It would be better if you learn them. All right. So let's look at a question. What should be multiplied to the number 120 to make it a perfect cube? So first of all, we need to find out the prime factorization of 120. Let's see whether it's a perfect cube or not. So it would be divided by 2. You get 60. Then it would be again divided by 2. You get 30. 2, 15, 3, 5, So prime factorization of 120 would be 2 cube into 3 into 5. So to make it a perfect cube, we need to have 3 square and 5 square as well. That is why then only you can have the number which is a perfect cube. So we need to multiply 120 with 9 and 25. So whatever result you get would be a perfect cube. Let's look at the answer. So now, in this case, the prime factorization is 2 cube into 3 into 5. And then, as we know that 2 occurs thrice, so that's fine. Now 3 and 5 occurs only once. So we have to multiply the square of 3 and 5. So you have number as 120 into 9 into 25, which is equals to 27,000. Now 27,000 is actually the cube of 30. So hence 27,000 becomes the perfect cube. Let's move further. Now how do you convert cube root by different methods as in positive and negative numbers? Let's look at this video.
We already know a little bit about square roots, for example.
Let me share the video with you. Please wait.
Example, if I were to tell you that 7 squared is equal to 49, that's equivalent to saying that 7 is equal to the square root of 49. The square root essentially unwinds taking the square of something. In fact, we could write it like this. We could write the square root of 49. So this is whatever number times itself is equal to 49. If I multiply that number times itself, if I square it, well, I'm going to get 49. And that's going to be true for any number, not just 49. If I write the square root of x, and if I were to square it, that's going to be equal to x. And that's going to be true for any x for which we can evaluate the square root, evaluate the principal root. Now, typically, and as you advance in math, you're going to see that this will change. But typically, you say, okay, if I'm going to take the square root of something, x has to be non-negative. X has to be non-negative. This is going to change once we start thinking about imaginary and complex numbers. But typically, for the principal square root, we assume that whatever's under the radical, whatever's under here, is going to be non-negative, because it's hard to square a number, at least the numbers that we know about. It's hard to square them and get a negative number. So for this thing to be defined, for it to make sense, it's typical to say that, okay, we need to put a non-negative number in here. But anyway, the focus of this video is not on the square root. It's really just to review things so we can start thinking about the cube root. And as you can imagine, where does the whole notion of taking a square of something or a square root come from? Well, it comes from the notion of finding the area of a square. If I have a square like this, and if this side is 7, well, if it's a square, all the sides are going to be 7. And if I wanted to find the area of this, it would be 7 times 7, or 7 squared. That would be the area of this. Now, or if I were to say, well, if I have a square, and that doesn't look like a perfect square, but you get the idea, all the sides are the same length. If I have a square with area x, if the area here is x, what are the lengths of the sides going to be? Well, it's going to be square root of x. All of the sides are going to be square root of x. So it's going to be square root of x by square root of x. And this side's going to be square root of x as well. And that's going to be square root of x as well. So that's where the term square root comes from, where the square comes from. Now, what do you think cube root? Well, same idea. If I have a cube, my best attempt at drawing a cube really fast. If I have a cube, And a cube, all of its dimensions have the same length. So this is a 2 by 2 by 2 cube. What's the volume over here? Well, the volume is going to be 2 times 2 times 2, which is 2 to the third power, or 2 cubed. This is 2 cubed. That's why they use the word cubed, because this would be the volume of a cube where each of its sides have length 2. And this, of course, is going to be equal to 8. But what if we went the other way around? What if we started with the cube, or what if we started with its volume? What if we started with the cube's volume, and let's say the volume here is 8 cubic units. So volume is equal to 8. And we wanted to find the lengths of the sides. So we wanted to figure out what x is, because that's x, and that's x. It's a cube, so all its dimensions have the same length. Well, there's two ways that we could express this. We could say that x times x times x, or x to the third power, is equal to 8. Or we could use the cube root symbol, which is a radical with a little 3 in the right place. Or we could write that x is equal to, it's going to look very similar to the square root. This would be the square root of 8. But to make it clear that we're talking about the cube root of 8, we would write a little 3 over there. In theory, for square root, you could put a little 2 over here, but that'd be redundant. If there's no number here, people just assume that it's the square root. But if you're figuring out the cube root, or sometimes people say the third root, well, then you have to say, well, you have to put this little 3 right over here in this little notch in the radical symbol right over here. And so this is saying x is going to be some number that if I cube it, I get 8. So with that out of the way, let's do some examples. Let's say that I want to calculate the cube root of 27. What's that going to be? Well, if I say that this is going to be equal to x, this is equivalent to saying that x to the third, or that 27 is equal to x to the third power. So what is x going to be? Well, x times x times x is equal to 27. Well, the number I can think of is 3. So we would say that x, scroll down a little bit, x is equal to 3. Now let me ask you a question. Can we write something like, can we pick a new color? The cube root of, let me write negative 64. I already talked about that if we're talking the square root, it's fairly typical that, hey, you put a negative number in there, at least until we learn about imaginary numbers. We don't know what to do with it. But can we do something with this? Well, if I cube something, can I get a negative number? Sure. If I say this is equal to x, this is the same thing as saying that negative 64 is equal to x to the third power. Well, what could x be? Well, what happens if you take negative 4 times negative 4 times negative 4? Negative 4 times negative 4 is positive 16, but then times negative 4 is negative 64, is equal to negative 64. So what could x be here? Well, x could be equal to negative 4. X could be equal to negative 4. So based on the math that we know so far, you actually can take the cube root of a negative number. And just so you know, you don't have to stop there. You could take a fourth root. In this case, you'd have a 4 here, a fifth root, a sixth root, a seventh root of numbers. And we'll talk about that later in your mathematical career. But most of what you're going to see is actually going to be square root, and every now and then you're going to see a cube root. Now you might be saying, well, hey, look, you just knew that 3 to the third power is 27. You took the cube root, you get x. Is there any simple way to do this? And if I give you an arbitrary number, if I were to just say, I don't know, if I were to say cube root of 125. And the simple answer is, well, the easiest way to actually figure this out is actually just to do a factorization, in particular a prime factorization of this thing right over here, and then you would figure it out. So you would say, okay, well, 125 is 5 times 25, which is 5 times 5. All right, so this is the same thing as the cube root of 5 to the third power, which of course is going to be equal to 5. If you have a much larger number here, yes, there's no very simple way to compute what a cube root or a fourth root or a fifth root might be. And even square root can get quite difficult. There's no a very simple way to just calculate it, the way that you might multiply things or divide it.
All right. So I hope you have understood the concept. Let me go back to the slides again.
Grammarly does more than catch errors. With Grammarly, you
Just
can
a
find really
minute,
good,
please.
no, perfect words that make your writing sharp, or explicit, or excellent, or distinctive.
All right, so let me get back to the slides. Okay, so what we have learned in this is how to find out the cube root of a positive and a negative number. All right, so let's look at the example question. What is the cube root of 1331? As discussed in the slides, as discussed in the video as well, you need to find out the prime factorization. So we need to find out the cube root of 1331. Now this can be further written as 11 into 121, and then 121 can be written as 11 into 11. So what do you have? 11 into 11 into 11, or basically the cube root of 1331 will become 11. So that's your answer. Let's look at the solution given. So cube root of 1331 is 11. All right. So these are the practice questions. Is the number 600 a perfect cube? So if we talk about 600, let's find out the prime factorization of 600. So prime factorization of 600 is actually 2 cube into 3 into 5 square. So these are not perfect cubes, as in to make it a perfect cube, we need to multiply it with 3 square and 5. So that means 600 is not a perfect cube. So answer is no. Next question is, we need to find out the cube root of 216. So 216, let's find out the prime factorization. This would be 108, 54, 27, and 3. So this would be 9 and 3. So prime factorization for 216 would be 2 cube into 3 cube. That means the cube root of 216 would be equal to 2 into 3, that is equals to 6. All right, let's check the answers. So first is no and second would be 6, as we discussed already. So this was the last part. I hope you enjoyed the video and I hope you have understood everything. Thank you so much and stay safe at home. Thank you.